Nisile Dlamini. We're going to be doing an example from the sampling and estimation chapter, which is chapter 6. We're doing exercise 6.8. And it reads, in an experiment conducted to see whether electrical pricing policies can affect consumer behavior, 10 homeowners in Johannesburg had to pay a premium for power use during peak hours. They were offered lower off-peak rates. For each home, the July on-peak usage, kilowatt hours, last year was compared to the July usage 2 years ago. Construct a 95% interval for the mean decrease in power usage. Comment on the confidence interval obtained. So this is the data that we have from the question. And since we're looking at 10 households, which means our N is equal to 10, and we're looking at the usage 2 years ago and from the last year, it means that we're looking at a dependent sample, which means we're going to use this equation, which is d bar plus or minus t n minus 1 of alpha over 2 times SD over root n. And since we're looking at a dependent sample, we're going to have to first get our DI values, which is going to be the difference between 2 years ago and last year. So you can either say this row minus this row or the other way around, but you just have to stick to it throughout. So I think I need y'all guys to help me with the values of what the DIs are. With the first one, 40. Second one, 5. 30. 55. 10. 35. 50. Okay. 50. And then 30. 130. Okay. 35. 39.
Is it
39.
Okay, so now that we have our DI values, you can punch it into your calculator when using the stat mode, and then that will give us our D bar. So in this case, our D bar is basically like X bar, but since we're using 2 different samples, it's going to be our average for our DI values. So in your calculators, you're going to look for X bar, and then you're going to record it as D bar here. So these are the values that you punch in, the DI values. So can someone help me out with that value?
42.9.
42.9, okay. And then can I please have the standard deviation, which we're going to call SD?
34.3461.
Okay, 34.3461. Okay, so now looking at our equation, looking at our equation, we now have this value, and we have this value, and we have this value, but we don't have this yet. So our Tn minus 1 alpha over 2, they said we're using a 95% confidence interval, which is, I'm assuming that's going to be 95% level of confidence, and that is 1 minus alpha is going to be equal to 0.95, where our alpha is going to be our level of significance, which is going to be 0.05. Therefore, our alpha over 2 is going to be equal to 0.025. And then our N is 10, so our T is going to be T9, 0.025. Can someone please look on table 3 on the T table what T9 of 0.025 is? 2.262. Okay. Okay, so now we have everything that our equation needs. So we're just going to plug in everything. 42.9 plus or minus that, which is 2.262. And then we're going to multiply that by our ST, which is 34.3461 over root n, which is root 10. So we're going to start with, I don't know, you can start with either one, but when you write, you have to start with the smaller one, which means you probably have to punch in the minus first. So can someone please calculate that lower bound? Can someone please calculate the lower bound for me? Are we getting 18? What? 18.3. Okay, and then has someone calculated the upper bound?
I got 67.47.
67.47. Okay. Which I don't know. Maybe some people rounded it off to 0.5, but it's the same thing. Okay. So the question says comment on the confidence interval obtained. So this is what we did when we began, yeah? We said these values minus these values to give us this, right? Which means what we're comparing is mu from here to mu from here. And since that is positive, so maybe our distribution would look, everything would be on this side. So this would be our 18, this would be 64. So the difference between these two will be somewhere in here, which means it's positive. And that implies that the mu from here is greater than the mu from here. And since we don't have 0 in this interval, it implies that there is a difference. So, I'm not sure what more to say. So yes, I don't know, let me just write that. So mu from 2 years ago is greater than mu from the last year. So going back to the question, they were talking about how the pricing policies can affect consumer behavior. So in the last year, that's when they started offering lower off-peak rates, which means that the usage decreased after they introduced that, which means that the low off-peak rates makes consumers more, I don't know, conscious of the electricity they're using, I guess. So yeah.